phones and listen and enjoy.
Thank you everyone for coming. First of all, I'm Crotti, that's my Twitter name. You can find the slides at this link, this URL. This is just the source code of the slides. But I will upload also the zip file with all the HTML generated on the Europython website after the talk. So I work in London for a startup called Wazoku. And first of all, why I want to do this talk is because I think until last year I was not really doing properly any testing, any unit testing or anything like this. And then I started to realize that I didn't feel good. I was always with fear that I couldn't change anything. I was always like feeling that I was doing something wrong somehow. And then finally I started to do it properly. And then I want to share with everyone this joy of testing and hope that someone will be inspired. So Python is a great language, as you know, but has a few things which makes life harder for us. So duck typing, so there are no types, there are no checked exceptions like in Java, and there is no compilation steps that tells you what probably you've done wrong. Compilation doesn't catch all the possible errors, even in other languages, but at least gives you a lot of things. So actually you have a lot of rope to hang you with. I just show a couple of examples of things that are, this should not show immediately. Well, anyway, so we have this function which, in a rare failure condition, report an error, and then otherwise does something else. So you probably don't see what the problem is, because this is a capital O and this is just a 0. So, but then in the rare failure condition, it will do this. So if you don't have a test that covers this part, you will never get the error that you want. So there's a testing code complaining about this. Another more interesting problem maybe is something that happened to me a few times, is that since strings in Python are just also iterable, you can, suppose by mistake you pass a string instead of a list of strings to a function which should uppercase a list of words, then what happens is not an error, but it still works, but it doesn't do what you expect. So you get a list of uppercase characters. So again, same problem. So then what is the solution? I mean, you can, Pylin, for example, can find some of these things, but of course it can't find everything. Like this example would have never been catched because it's actually a bug in your code. I will only concentrate on unit testing here but I mean the same principles will apply. So what is a unit test? It's a test which is small, is isolated, is localized to a certain part. So if it fails, you should know with like 5 lines of confidence where was the error. It shouldn't have external dependencies, and very important, it should be fast. For external dependencies, I mean it shouldn't touch anything which is file system, database, network, or depend on any global state whatsoever. This is, for example, not a unit test because here I have I connect to MySQL in the setup. I create a cursor, I maybe insert something, and then I test that my report, which actually calls MySQL again to do things, will have the length 10. This can be fine. This can be a maybe integration test, but shouldn't be a unit test. So I think a test-driven development gives you a change of perspective. So since programmers are lazy, as you can see from the picture, the thing is that how do I make my life easier? What is the thing which I can test more easily? Well, it turns out that things that you can test more easily are actually functions that are pure, that don't have any side effects. So this is the simplest possible example of what you can do. You have a very stupid sum, a very stupid subtraction, and these are functions which take input and return always the same output depending on the input. They don't depend on anything else. So to test this, you can just make a table of input-output and then do all the assertions you want. You can even combine these two things and then do a loop relying on the mathematical property of the thing. So that would be great. Could we always do these kind of things? Well, sadly we can't, because life is not so simple, and we have to interact with databases, we have to interact with file systems, and so on. So let's see this first example of side effect. So anything which, in addition to returning a value, also modifies some states or has an observable interaction with calling functions or the outside world is actually a side effect. So this is first example is using a global variable. I have a global variable which I declare somewhere with some value, and then every time I call this function, I increase it, and then I use it for actually the return value of this thing. So I call twice this function, one after the other, with the same input, and I get two different results. So yeah, this is an example of how, depending on the global state, is a side effect, and it makes things harder to test. Another example is this. So we have a report function which uses the ask time function from time module, and this time module actually depends on the system, depends on the time. So also, how do I test that the string returned by this thing is what I want it to be? So one way is dependency injection. Dependency injection is a technique that allows you to remove hard-coded dependencies, like making them in this way. In this example, for example, I make this an optional parameter, ask time, no, a default parameter with ask time, and otherwise I can pass something else. So in a test, I can simply pass a lambda function which returns what I want, and then I can test this. So I don't particularly like this approach in general, because unless it makes sense for production code to have parameterized this thing, then somehow you are doing something that is only useful for testing in the code. So like you hide the logic, you do extra things which make the code more complicated for no real benefit. So is there another approach? Yes, luckily in Python there is, differently from other languages. Suppose we have a file library.py that contains a function, which is like a library function, just return an integer. And then we have a program that uses that library. And then inside this program we have a function which calls this library thing. Now the first time I call it, now I will show you what happens, but now I call it, then I change this library.labfunc to something else, and then I call it again. What do you think should happen? I show you what happens. So I do import prog. First time I get 1000, the second time I get this. So just to show you this, the same file. Sorry. So this is prog.py, and this is library.py. To show you even more precisely, go to prog.py. I can even do this. I can do a trace back here, and then I can do it again. I know if I put the trace back, it doesn't. Well, I can just print what it is. Because now it's already imported. No? Sorry. Even if I delete it, it still doesn't. Okay, yeah. Well, anyway. Now it shows that the first time is a libfunc, and the second time is the lambda function which I define. So this is maybe surprising, but this is because the first when I change this thing, the name binding is found dynamically the second time, every time. So if I change this here, this was not bound to the thing which was originally imported, but it's still able to change dynamically. And that's I think, this the main reason why in Python we can use libraries such as the mock library, which allows you to automate this fiddling process between of modules and different functions. So what it is useful for is actually to be able to remove some extra dependencies, making them deterministic and non-depending on any global state. There are a few problems with that. The first problem is that every time you mock something out, then you are one step away from your real system. So you actually have one more thing to maintain. You have if you say this should behave like this, but I don't want to call this, and then you change the original function which you mock, then you also have to change the mock. So unit testing, you should try to minimize the number of times you mock, but it's still very, very useful. One nice concept which I found in a talk from Gary Bernard is functional core imperative shell, which is functional in a functional programming sense, which means that you should try to write all your core logic in a functional programming way where you have as less side effects as possible, and then around that you have a shell with an imperative shell which actually has side effects and all these things. But at least this functional core is possible to test it in a somehow perfect way without doing mocking, without doing anything, but just calling things and checking the return value. Should be great. So let's see a first example of how a mock object looks like. So we have a complex object, and then we have an object which instantiates this complex object and then calls this method on it. If I want to test this thing, but I don't want to call this method because it's very expensive, no? I can still I still can create this object, and then I use this patch function which replace at runtime this object with something else which I just created here. It's a fake complex object, and this mock object is created passing as a spec this object, so it will automatically have the method as you declare it. So, but I show you very quickly how you can use the mock library. I will not do a full talk, but just if you haven't used it before, I think it's very useful. So here I create the mock. Then what I can do is to do something. If I say call function, and then I pass an argument, for example, right? It doesn't do anything because I don't have a return value or anything. But I can already see, for example, I can see that func called, and it tells me true. So you can create these objects, do something with them, and then check what happened to this object. I can also say mfunc return value equal to 10. So then I say mfunc and I get 10. So in this way, I hard-coded the return value of something to something that should be the same as the calling function. Then you have many more possibilities. You have a lot of you can do a lot of assertion, assert any call. You can see the call args. You can, here is mock calls, reset mock. You can do many things. Then, yes, patching is the thing I was showing you before. Basically, we can suppose we have something that relies on the file system, which is filter directories, and use the listdir directory, and then it simply is like filtering and yields something. I don't want to call listdir in a unit test, so I can patch it and make it return the list that I want. And then I can do some assertions with that, and I'm actually testing that this filtering works correctly in this case. Now let's change slightly topic. I think I will first show you, just playing briefly, and then if I have time I will show a full example of how we can do it. But basically, the TDD cycle of development is that first first of all, you start by writing the test. Then you watch the test fail to check that your test makes sense. Then you write some code to fix it. You run it again. You write some code to fix it. You run the test again to see that they're fixed. And then optionally, you refactor if you have something to refactor. I will try to show a full example if I have some time in the end. But first of all, yeah, this is like a test. One important thing which I want to stress a bit more is make it fail, because it's something that many people maybe don't do, and then I will explain you. Can you see something wrong from this test? Exactly. And that, yeah. So I call it without brace, so I just call a method. But the problem is that this works because this is a function, it's a method which evaluates to true as a Boolean. So even if I have a bug here, this would always work. So if I haven't checked that the actual test fails before I fix it, before I write the implementation, then I can show you that it's true. So, if I remember what it was. Passing test, okay. Can you see something? So now, suppose I run it like this, and it works. But now I put a bug, and I run it again, it still works. So instead, if I do this, it fails correctly. So the first thing which I should have done is to check that this actually fails, and then I could have fixed it. So that's one important thing which many people don't do. Now I want to show you one possible way that you can extract some somehow pure function starting from something which is not really good to me. This is a function which does too many things. So it first call ls, get the output, then here it filters something from this output, and it appends to a list, creates a list. And then after that, it connects to the database, and then it inserts the value that they extracted from this file. It doesn't make any sense, but it's just an example. So how would I do it? So the problem with this thing is that how do I test it? I mean, it's complicated because if I want to do a unit test, I should mock this p open. I should mock the MySQL DB connection. There's way too much to do, so it wouldn't make any sense. So one way I can do it. So I start from this situation, and here I highlighted somehow the things which are done. Can you all read? Big enough? Yeah? Then I go to the second version, which is in the second version, I extracted the run ls function, and here I just call it. So ls is encapsulated in a different thing. Then I'm still not happy. So I also extract the output filtering. So first I get the output from ls, then I filter it here with this other thing, and then I do the rest as usual. But then I'm still not happy. So I extract also the function to update things to database. And now this became a lot simpler. But what happened now? I think the very interesting thing now is that we have something which is filter output that doesn't depend on any global state or any external dependency. It doesn't depend on the file system, doesn't depend on the database. So what I can do is I can actually write a unit test for that. So here I have a test filter output which takes some lines and then asserts that filtering these lines you get the result that you want. And then I just left everything as it is because this still would require not unit test, but something more smart than that. So now yep.
But are you not doing the same like you did, when you said about injecting parameters into a function, that we only did that for testing purposes?
Yeah.
By doing that, if that function is only used by the other function, are you not modifying the code just for testing purposes?
Well, no, because I would do this anyway, because I don't like to write. I like to write code like this, because if you write code in this such a more modular way, then you see, it's more likely that you start to see that things are somehow repeated in other places, and then you start to reuse the same things. So this is just every function just does one thing. It's still a good thing anyway. You're not adding things just to make the test work. As a side effect of doing this, then you get also some like things that are more testable. But I don't think it's just for that. Yeah. So that's like the final status of this example of refactoring. So it's longer, but it's more clear to me, and it's more testable and more safe. Then let's see an example of what is test coverage and how it works. This the library which is used by actually everyone is a coverage of Pi from Ned Batchelder. How it works is that has a C module and has a C part and the Python part. The C part can be disabled if it doesn't work, but then it's slower. And then it sets a tracer function, and then it just runs all your code, and then keeps track of all the things that are executed, and then it shows you a report of the lines that were never passed through. I can show you an example of this. So I have a file which all I want to do is to So yeah, I have a simple, very stupid function which is like a smart division, which takes two numbers, and then if it's B0, it raises an exception. Otherwise, it will try to divide. If the division was like integer division, sorry, like 4 divided by 2, then I get this. Otherwise, I use the float. It's just to show an example. It's not really. Now, if I run this thing, let's test here, cover report with coverage. This moment, forgot what was the option. Coverage with coverage, cover HTML, cover HTML. Okay. Right. So I get 0 coverage because I'm not testing anything. Now, for example, I want to check that the division worked correctly, that the division by 0 raises an exception. So I have this test. We say test division by 0. We just simply say with self-assert raises exception, which is a way in a unit test library to say this thing in the body has to raise an exception of this type. Otherwise, I will complain. It's very useful and everything. So now I run it again. Oops. And I get 60% of coverage. The nice thing is that I also have I also have created, what is it? A nice report, HTML report from this thing, which shows me which are the lines that didn't get executed. So everything, well, here everything was executed, of course, but then the only thing which I actually tested is this. It never went through this. So now I just check that this also works. Testing the float division. I use almost equal now because with floating numbers you can't do exact checks, but you have to like use some decimal places of approximation. So now I do it again. And here I see cover 80%, and then I get 16 and 18 and so on. So if I go here again, I see now the only thing which didn't get executed is this. So now I do it again, and now I should get 95%. Yeah. So now the only thing is this, but okay. So this is a very nice library which you should all use, and I think is very useful also when you look at the new project, I think, to see what actually is covered, what is not covered, even if it doesn't tell you everything, because sometimes if you have a bad test, it will still execute something even if it doesn't actually test anything. So the test has to be also, has to make sense, but this is already a very good, good hint of what is going on. Then I just want to show you quickly what my setup is for testing, which is it's not perfect. I'm open to other suggestions, but maybe will give some inspiration to someone. So I divide tests in different categories, in different directories. I have a unit test, I have an integration test, maybe I have performance, I also have security test, and so on. And then I have a run test script in the root directory which just runs only the unit test, unless I pass some argument, and then also all the integration tests are run. Then I have a coverage SH thing which does this, and then I show you in the real code how it actually looks like. So what's up? Now if I do run tests, as you can see, I ran 112 tests in 0.120 seconds. And this is because all these tests run, like, don't touch anything. If I try instead to run all the integration tests, it will take a lot longer. And the run test script is simply doing this now. So if I don't pass anything, it will run the unit test. Otherwise, it will also run the integration test. Very simple. Then the important thing which I wanted to stress about, which I implemented, is that everyone has to add a hook in his Git commit. So if I go to Git hooks pre-commit, this is simply a symbolic link to this run test function. So if I now modify something in my library which makes something fail, for example, entity, well, I don't know. Let's see what I can make fail. Suppose if I comment out something, it will fail, I hope. Yeah, so I run them now to be able to see, actually, yeah. I can run them easily like this. So I see all the things that are failing. Now, if suppose I try to commit this, I do this commit, and unless my hook got messed up, yeah, it didn't work. So I still have state changes, and the commit didn't go through. So now if I unstage, I remove this, yeah. Okay. Yeah, so now maybe I can go back to, yeah, well, anyway, first of all, the conclusion for this, I think tests are really good. Tests are also a great way for documenting things because it really shows how you should use something, and they are never get out of date. Because if they are out of date, they just don't work anymore, differently from documentation. Testing Python is really easy because you have a lot of powerful tools, and you have libraries, and you have all the things which help you. And then testable code is a lot better than non-testable code. I don't know, I can go back and show an example of the cycle of TDD, or do you prefer more, maybe? I don't know, I'm not sure. Well, okay, I'll try quickly to show how you can be done. Because I still have 5 minutes.
Last question and answers.
Huh?
We also have 5 minutes for a question and answers.
Yeah.
So 10 minutes in total.
10 minutes in total. Okay. Well, unless you have questions which take longer, but okay, ask.
Can you tell us a bit more about functional core imperative shell?
please repeat the question for work?
Yes. He asked me if I can explain something more about functional core imperative shell. Well, there was a talk from Gary Bernard, which is a guy that has like a destroy all software website. Don't know if you heard. And then he has a lot of talks about testing, programming, all these things. And this was, I mean, the concept is somehow simple. It's a way that you create your own core objects, and then all these objects should just be done in a functional way. So they should be you just create something that will return you a new object all the time. You don't modify the state. You don't have global state, and so on. And then wrapped around all this core functionality, which is all somehow pure and nice, you can put around a shell of imperative things, which actually then use the DB, use this, use that. I do the same for my project, because we have all these core objects which don't rely on anything external, and then we have another layer around that, which allows me like to just modify. When I do testing, I don't have to mock anything in the case, and I know that it really works, because the thing is that, again, when you mock, you somehow you really give away something. So you say, okay, I know that this thing will return this, but then you change that, you forget, and then it still works, but maybe it doesn't work anymore. So that's the problem. Yep.
I always think it's a bit of a challenge to get somebody who isn't using TDD to do it, because they think it's a speed impediment.
Yeah.
Makes them slower. I think that maybe there should be, I don't know, like a tutorial or something where things are a bit more explained, especially about the process.
Yeah.
While you usually don't start out with a code base that is easy, nice to read, and easy to test, and then you just put some tests on top. So you have a little bit of code and a large project in front of you, and you need to somehow move tests along, right? What's your experience?
Well, I had this experience exactly, because I went now to a startup. Well, I went to work where there were really no real tests in general, not much. I mean, and now after like 6 months, we have I don't know 500 unit tests or something like this. And I was lucky because they all started to do it also. But it is true. It doesn't take. It takes time for everyone to get used to do it. But I think you can't really convince someone easily, because if they don't see the benefit, it's hard to convince someone. They have to see themselves that it's better. And then all you can do, all I did at least, is to write all possible examples, all possible tests, all the cases that they can do. And then in the beginning, they just somehow copied what I've done and changed it to their purpose, no? Which is fine. So then they learn how to do it, no? I think it's the only way, because if you say, okay, now you have to test this thing, but I don't know how to do it. I can't take half an hour to understand how to test this particular thing, and then they don't do it. But if somewhere else I've already done something similar, then I just say, go there, look, and do the same, and then they will see the benefit, because I mean there is huge benefit in general. So.
And also, have you heard of FlexMock?
FlexMock. Yeah, I think it's similar library. I think I'm using mock library because also it's the one which is included in Python 3.3, and I think it's the best one. So I haven't really tried out this library.
Hello, and quick question. Why don't you run your test inside Emacs, for example?
I do. I mean, okay. Maybe I was not showing well enough, but if I now remove something here and I press F5, I also have show key. No, I don't. If I press F5, it will create a compilation buffer where it will, then I can jump with tab to the thing which I want, and then I press here and it goes me to the test that is failing.
And do you have the same trick for the coverage, for example, that jumps to the line?
Yeah, there is something. There is a coverage.el. There are a few things. I tried that, but then I don't know. I had to. I didn't have. No, there is also something that shows you on the left, like with a small marker, the lines that are not tested, which is really nice. But then in this project, I had not enough coverage to. It was too depressing, so I had to remove it.
Thank you.
No problem. Yeah, and this compilation buffer disappears automatically after like 1 second if everything went fine, which is another thing. So I don't have to remove it manually.
Just a small comment. I think it's very good to have your shell script to run everything easily. You don't have to think about it every time. We went just one step further and put everything in the make file. So we just have to make test, make full,
yes.
make...
Yeah, I think I have a make file somewhere. No, maybe not here. Yeah. Yeah, for me it's the same because I have this dir local variable which simply does it. So it knows what the compile command is, so I don't have to type anything anyway. But yes, in general.
Just a quick question. You said you work for a startup. I work by myself, and sometimes I have clients and I have to try to get them to pay for testing as well. I don't know how small your startup is or big it is. Do you have any tricks to to convince them that it's good, but it takes time, and that basically I'll be coding double the time?
I don't think it's double the time. I don't agree, because for me every time if every time I have to test something manually that I don't have a unit test for, it takes time. I mean, maybe it's I would say maybe it's 20% more the time, maybe. But then also that time is time that you take away from the debugging later. So I think in the end you spend less time than more. But my startup is not, we don't work with clients, we have our own product, so it's a bit different. But still we have tight deadlines, of course, and we have things like this. But for me, simply the answer is that it's not done until there is not it's not tested. So that's the only way you can.
I can comment on this issue, and what you need to do is to explain to your customer the concept of technical debt, which means that they have to look at the testing over the lifetime of the product. And you're actually amortizing the testing for many, many years, because every time you need to do a change, refactoring, etc., you're paying for not having the tests.
Yeah, exactly.
So TDD isn't only about unit tests. As you said, there's integration tests as well.
Yeah.
And I always think that's where it gets complex, but then I'm almost always totally lost if it goes into the browser. And I know there's, Selenium and WebDriver and all these things. Then if we really talk about TDD, then eventually you would need to get into, I don't know, like image-based validation. If you are a web developer, for example, right, you would like to go and ensure that a certain thing generates the same output. Maybe you can talk about your experiences now.
Yeah, well, I think the problem is that TDD, if you have to say like test-driven development, and it means that you have to have a very short cycle from when you write the test and when it fails. I think the problem with browsers is that like testing Selenium is very slow and annoying in general. So, and it's also, it depends a lot on a lot of things. So I think, yeah, in theory, yes, you're right. But actually, I write them in different times somehow. I write first all the unit tests, then the code, and then when I want to prove that the whole thing works, I write integration test and Selenium test and so on. But I don't use like this Selenium test. Maybe I should, I don't know. But because it's just such a pain that I can't handle it. Yes. Yeah. I'm not patient enough.
Okay, that was about it. Then,
So yeah, I will upload the slides on the website now if you're interested. And there is also all the code I actually work with this in this link. Okay.
okay, so
The example that you gave with Word, with looping over a single string,
Yeah.
that deleted a large cluster of OpenStack cloud servers in our system. Because it was a delete call on the host name. And so it deleted everything with a W in it.
Oh god. Yeah, yeah.
That was good.
I want to say that I think you're confusing TDD with doing like lots of testing. I think TDD mostly tries to like direct